So now we're doing Module 2, Lesson 4, solving equations with variables on each side. Now, here is an equation that I have variables on both sides of the equal sign. So I have one here and one here. Well, the whole goal is, on all the ones that we've done so far, we've always had A equals. So I need to get it so that the variable is only on one side of the equal sign. Now, most of the time what I like to do is move the smaller of the two coefficients. So if I look at these two coefficients, the numbers that's sitting in front of A, which one's smaller? The 4 is. So that's the one that I'd move. So I'm going to subtract 4A from both sides. And just for you guys, I will put that line down. Okay, I get 5 plus 3A equals, this turns to 0, it's gone away, minus 13. Or sorry, negative 13. Make sure you bring down the negative. That is one of the biggest issues, is forgetting our negatives. So now I have my variable on one side. So now I just do it like I did all the other problems I've done in the past. I subtract 5, I get 3A equals negative 18, divide by 3, and get A equals negative 6. Now, I personally would make sure that I did it correctly, so I would plug it back in. So we're replacing all of the A's with negative 6. So 5 plus 7 times negative 6 equals 4 times negative 6 minus 13. 5 minus 42 equals negative 24 minus 13. Negative 37 equals negative 37. That worked out, so this is our answer. Okay. So now we have a word problem. So let's look at this word problem. Oops, sorry. It says the results of 2015 Nathan's hot dog eating contest are shown. So if I look over here, I have Matt, and he had 62. Mickey has 38, and they ate that in 10 minutes. So in 10 minutes time, Matt ate 62 hot dogs, Mickey ate 38 hot dogs. That's including a bun. So it says, suppose the men and women's winners, Matt and Mickey, decide to compete against each other. To make the competition more interesting, Matt will not start until Mickey has eaten 20 hot dogs. Assume that Matt and Mickey eat at the constant rate. Constant rate, guys, remember? Constant rate, that means it doesn't change throughout the competition. Based on the number of hot dogs eaten in 10 minutes, so based on this information right here, how many minutes after Matt starts eating will they have eaten the same number of hot dogs? Okay, so same number means that they're equal to each other. Okay, so let's look at this. Number one thing, what are we looking for? How many minutes? How many minutes? Okay, that's what we're looking for. So M is the minutes, the number of minutes for which Mickey and Matt have eaten the same number of hot dogs. So now let's look. The next part says Matt has eaten 62 hot dogs in 10 minutes. Well, I need to know the rate of that. So to find the rate, I do 62 divided by 10, because that's 62 hot dogs in 10 minutes. 1 minute, that's going to be 6.2 hot dogs in 1 minute. The number of hot dogs, so he has eaten in M minutes. So this is our rate, so 6.2 in M minutes. Okay, now let's go down to Mickey. Mickey has had 38 hot dogs in 10 minutes. And if we do 38 divided by 10, that's going to get us 3.8 hot dogs per minute. She's given a head start, right? So she gets to eat 20 hot dogs first, and then math starts. So her equation is going to be 3.8 m plus 20. So 6.2 m equals 3.8 m plus 20. Okay, so as I look at this, I have variables on both sides. But do you notice on the left-hand side there's no constant? Okay, so there's no constant over there. So I want to move all of my variables to the side that doesn't have that extra constant. Now, mind you, 3.8 is smaller than 6.2, so I would have done that anyway. I personally would have. And I'm going to do it over here because I don't like how they did it. 6.2 m equals 3.8 m plus 20. So I'm going to subtract 3.8 m. When I subtract that, borrow, so that's going to be 4, that's going to be 2.4 equals 20. Then I'm going to divide by 2.4 on both sides. And when I divide by 2.4 on both sides, I'm going to get 8.3. Okay? So, 8.3 minutes. They will have eaten the same amount. I need to look at something. Okay, so that's not just 8.3. I rounded it to the nearest tenth. That's what I thought. So that's going to be 8.333333333. Well, that's the same as saying 8 1/3 minutes. Okay, so now let's look at the next one. The next one says basketball. Nolan and Victor were two of the top scoring freshman players in the college basketball conference last season. The table shows how many points Nolan and Victor, so we have Nolan, we have Victor, scored and how many games they played last season. The points Nolan and Victor scored this season will be combined with the points from last season. So combined, wouldn't that mean that they added to it? Okay, from last season. I'm actually going to write that. Maybe I'm going to write that over here. So we're going to have last season plus this season. Okay? So it says this season, Nolan is hoping to catch up to Victor and have played the same number of career points. So they're going to have the same number of career points. Assume that Nolan and Victor play every game and score the same constant rate. Okay, here we go. So first things first, I need to know what Nolan's rate is. So I'm going to do 750 divided by 30. If I do 750 and I divide that, I'm going to get 25. Okay, then 782 divided by 34, that will get me the rate for Victor. So that would be 23. Okay? And what are we trying to find? The number of points. So, let P equal the number of points. So we're going to write an equation. So this is over here. This is Nolan, because the rate for Nolan is 25 P, which we don't know how much they've done this season, so that's why we're doing a rate. But how many total did they have last season? 750. What was Victor's rate? So Victor's, this is his rate. He was 23. How many total points did he have? He had this. So now we're going to solve that. Come over here. We're going to do 7, How about we start up here? 25P plus 750 equals 23P plus 782. Again, I want my variables to be on the same side of the equal sign. So 23 is lower, so I'm going to move that one. So I get 2P plus 750 equals 782. I want 750 on the other side. I get 2P equals 232. I divide by 2. And I get P equals 16. Awesome. So now we're going to come over here. Now remember when we did PEMDAS that you have to do things in a row. So parentheses comes first. Well, can't do anything inside the parentheses. Okay? There are no exponents, but there is multiplication. This out here is being multiplied in here. This right here is being multiplied in here. So, the very first step I need to do is distribute. So when I distribute, 7 times n is 7n. 7 times -1 is -7. -2 times 3 is going to be I didn't mean to do that. Well, this is going to be interesting. This will be -6 minus 2n. I think I'm going to come over here and do this because I don't like what it's doing. So I need the n's on the same side, so I'm going to add 2n to both sides. I get 9n minus 7 equals -6. Get 7 to the other side, I'm going to add 7. 9n equals 1. I'm going to divide both sides by 9, and I get n equals 1/9. Okay? So we're going to do the same thing with this problem right here. So I have 7 times n minus 2 plus 8 equals 3n. Oops, nope, try that again. 3 times n minus 4 minus 2. So when I do this problem, okay, so I have to do the distributive property first. So I'm going to multiply here and here. So 7n minus 14 equals, I'm going to multiply here, 3n minus 12 minus 2. Now, before I can do my next step, I need to combine like terms. These two are like terms. So when I do that, I get 7n minus 6. On this side, these two are like terms, so I'm going to combine them. So 3n minus 14. Then I'm going to move the n's to the same side. I'm going to subtract 3n from both sides and get 4n minus 6 equals negative 14. I'm going to add 6 to both sides, and I'm going to get 4n equals negative 8. Divide by 4 and get n equals negative 2. Okay, this next one. As I decided, I don't like how they did it, so we're going to write it 5y equals 12y plus 16 all over 4. Okay. And like what we did before, we got to get rid of that fraction. So how do I get rid of that denominator? I multiply both sides by that denominator. This will cancel out, and I will get 20y equals 12y plus 16. And again, on the left-hand side, you just have the variable with its coefficient. You do not have a constant. So I'm going to move everything, or all of the variables to the left-hand side. So I'm going to subtract 12y from both sides. I'm going to get 8y equals 16. I'm going to divide by 8. I'm going to get y equals 2. Okay. Oh, here we go. Fun stuff. Geometry. Find the value of x so that the figures have the same area. So we have the area of the rectangle equals the area of the triangle. Okay? Area of a rectangle. Length times width, base times height, whatever. Over here, it's 1/2 the base times the height. So if I look at the rectangle, I'm going to multiply these two numbers together. So 5 times x plus 4 equals, and this right here, I take 1/2 the base, this is the base, and this is the height, and I multiply them together. So I take 5 and I multiply it through, 5x plus 20. Over here, you do multiplication straight across. This times this will get me 6. 5x plus 20. Now I need to distribute. 6 times 2x will get me 12x. 6 times negative 6 will get negative 36. Now, this time the 5 is the lower coefficient, so I'm going to move this to the right-hand side. 20 equals 7x minus 36. Okay, I want to get the variable by itself, so I'm going to add the 36 to the other side, and I'm going to get 56 equals 7x, divide by 7, and get 8 equals x. Okay, so now let's come down to this one. It says, find the value of x so that the figures have the same area. Okay, so same area, that means they equal each other. They're both going to be rectangles, so length times width. So I look at the first one, and I take x and I multiply it by 10. Oh, but this is weird. Well, if this was 7, I would take 3 plus 7. If it was 8, it would be 3 plus 8. So it's x, so I'm just going to take 3 plus x. So it's 6 times 3 plus x. Now, could you write it x plus 3? Same thing. So I need to do my distributive property. 10x equals 18 plus 6x. The variables need to be on the same side of the equal sign, so I subtract 6x from both sides, and I get 4x equals 18. I divide by 4 on both sides, and I get x equals 4.5 centimeters. Okay, next. Now, we're either going to have one solution, no solution, or infinitely many. All the ones that we've done so far have been one solution. You've come up with one number. Well, what happens when I have things like 6, 10 plus 3y? Okay, so let's look at this. 6y minus 30 equals 20 plus 6y. So if I subtract the 6y's from both sides, negative 30 equals 20. Is that ever true? Will those numbers ever equal each other? They will not. So that is actually no solution. What does that mean? Well, let's look at it. An equation has no solution if there is no value of the variable that makes the equation true. So what's going to happen is no matter what I plug in for this y or this, I mean, they have to be the same numbers because they're both y. It'll never make the equation true. So there's no solution on this. Okay, on this one, I'm actually going to write it here. So 7x plus 5, x minus 1 equals 12x minus 5. So if I look at this one, 7x plus, I multiply here, 5x minus 5 equals 12x minus 5. Combine like terms, I get 12x minus 5 equals 12x minus 5. Look at that. This is exactly the same on both sides. That means that this is going to be, okay, I have always taught it as infinitely many solutions. Now, this book teaches it as identity. An identity is an equation that is true for all values. So identity and infinitely many solutions are the same thing, okay, in this instance. So what it's talking about, identity means they're exactly the same. This is the reflexive property. They are exactly the same. So this is identity. Is identity. Okay, next, I think there's one more problem. Oh, so we're deciding what these are. So if I do this problem, I multiply here, I get 8g plus 48 equals 5g plus 3g plus 48. So this is going to get me 8g plus 48, equals 8g plus 48. They're exactly the same, so that's the identity. This next one, I'm going to use a different color. So this one's going to be 5x plus 5 equals 15x minus 12 minus 10x. So 5x plus 5 equals 5x minus 12. If I subtract the 5x from both sides, I'm going to get 5 does not equal negative 12. So this is no solution. I'm going to come out. Oh, this one actually is going to be easier. Okay, so on this one, I would subtract 3w from both sides. I would get 2 equals 4w. Divide by 4. Look at that. It's 1/2 is equal to w. Okay, so 1/2 is the answer. Then last but certainly not least, I come down here, I multiply, and I get 6b minus 3 minus 7 equals 6b minus 10. 6b minus 10 equals 6b minus 10, so this is the identity.